Okay, you probably need some graph paper for this one, or you can just sketch it out, that's fine. So jot down these on your graph paper if you'd like to. Pause the video, take a minute to do that. So we're going to sketch the graph of each function. This is piecewise defined functions, where you just have different pieces that are defined for certain domains. So f of x has this function 2x minus 1 when my domain is x greater than 2. So I want to look at when x is greater than 2, which is right here. So here's 2 on my grid. And when x is greater than 2, I'm going to have a linear. So it's going to be, I could just, for now, before we do transformations, you're just going to plug in any value. So I obviously can't include the 2 because it's a greater than, not greater than or equal to. So I might just pick the next big thing, but I want to know when that open circle, where it's going to occur. So I'm going to just do some work off to the side over here because I don't think that'll get too much in the way. But if I do 2 times 2 minus 1, I'm going to end up with 4 minus 1, which is 3. Okay, so that would be my output when I put 2 in. So if x is 2, then output is 3. But remember, I can't actually have it equal, so I'm going to just put an open circle. Then if I do the next one just to get an idea, or you can use that in your slope, go up to over 1. I know it should fall there, but you could pop in another number. Say you want to get a little further up, you could do 2 times, we'll put in 4 minus 1, and I'd get 8 minus 1 is going to be 7. So I could put in 4 and then 1, 2, 3, 4, 5, 6, 7 right up here. But you can also just use that as your slope triangle there. I don't have the laser pointer on this one. So this would be the piece that's defined by 2x minus 1 for that specific domain. I'm not going to write anything further down here because it has a different rule. So now I'm going to use the piece. Let me see if I can pick up a different color here. I have to use a different tab or app to get my grid going. So I'm going to pick blue. Okay. So for this one, anything less than or equal to 2, I am going to use this function. So 2 minus 2, I'm going to start with that. I would get 0. So that's down here, and it includes 2, so I'm going to put a solid dot. Then I can, again, just use my slope if I wanted to, but I'm just going to pick some values that are less than 2. So I'm going to pick 0. So if I do 2 minus 0, I'm going to get 2. If I put in, like, say, 6, oops, I want to do 2 minus 6, and I would get, let me just correct that. That should be 2 minus negative 6, so that I can get a lot further down. Because remember, I can't pick 6 because that is outside my domain. That would end up, I would have to use this rule up here. So 2 minus 6 would be 8. And so let's see, 1, 2, 3, 4, 5, 6. So that's my negative 6. And then 1, 2, 3, 4, 5, 6, 7, 8 right up here. Okay. Again, I can kind of use my slope if I wanted to. Oh, that's a bad line. I do have a ruler on this, but it's pretty hard to set up. All right, so you would usually use a straight edge. So that's the other piece. So I would be done with that problem. Number 2, if you want to try that one on your own, go ahead. You just pick a couple of values in the domain, maybe 3 if it's a curve or you're not familiar with the shape, because a couple of these are going to be a little different. They're not linear. So if you want to pause the video and then check back, or I'll just go ahead and do it. So x is less than 0. So anything down this end here, I'm going to use x squared. So if I pick, so this one should be pretty easy to do. So if I pick -2 and I put that in up here, -2 squared, that's going to equal 4. So 1, 2, 3, 4. Okay, if I have 0, I have to have an open circle. 0 squared is 0, but have an open circle because it's not equal to. I can also pick 1. 1 squared would just be 1. And so you have this shape, but don't continue on. Just only leave that piece of that parabola. So that's the piece defined by x squared for this specific domain. X is less than 0. One of the other ones I'm going to do is 1 if x equals 0. So that's kind of a nice, easy, quick one. So let's pick an orange dot there. So if x is 0, it's 1. And that's it. Just draw the dot. Leave it. Not going to connect it to anything. That's kind of tempting for people to do sometimes. And then this last one I will do in the red. So we have for anything greater than 0, for x we put in, we are going to have it be the cube root. So if we have 0, we would just end up with, or we actually can't have 0. We would have an open hole there, right? Okay, so cube root of 0 would just be 0. And then if I picked another one like 1, cube root of 1 would be 1. So kind of put that there. If this were a solid dot, that would take precedent and I would fill in an open, but they're both open there. And then cube root of 8 is 2. So 1, 2, 3, 4, 5, 6, 7, 8. So we're just getting the general shape. Okay. So those would be my pieces, and then I'm finished from there. So that's it for this part. We will hit on the piecewise later when we do more graphing. One thing I want to point out too is the range. So let's go back really quickly and look at the first one. So the range and domain were given, right? So domain for this blue piece was the x greater than 2, and the range for that is going to actually start for that piece won't start until 0, right? And then it goes up until well, actually this continues on to infinity because we're not bounded there. So it would go 0 to infinity. So I'm going to write it as what are we doing? F. Okay, f of x is greater than 0. So anywhere in that range. Okay, and the same holds for the other piece also. Sometimes we have you clump the total domain together for those. So our overall domain would also include x greater than or equal to 2. So it would be all real numbers in the entire thing. But for now, we're just going to separate them out. Again, here for the g function, the range if I'm looking at the overall range, we wouldn't have 0, but we go from, we have positive infinity from 0, but not including 0. And this one would also just continue to go to positive infinity. It doesn't ever curve down. So once you learn a little bit more about your library of functions for graphing, we'll do more with that. But I hope that helps get you started in learning some things about piecewise, and you'll hit some in your electronic homework too. Have a great day.